So I said that this formula holds for all different kind of waves. So let's apply this to radio waves. So we know that radio waves here, and so we want to find, for example, the wavelength of a radio station. So let's pick a radio station. Okay, so just pick a radio station at random. Okay, so I'll pick one. It doesn't really matter. We have a radio station, and you need to know the frequency. So let's say 101.1 megahertz. So that is a radio station. It's on the FM dial. So the megahertz is the frequency, and radio waves move at the speed of light. So that's going to be the frequency. Speed of light is 3 times 10 to the 8th meters per second. And so what we find is that the wavelength, okay, is going to be c divided by f. Okay, so that'll be 3 times 10 to the 8th meters per second divided by 101.1 megahertz. Mega is 10 to the 6 hertz. Okay, and so what we get is 2.97 meters. Okay, remember, a hertz is 1/2 So that means that radio station has a wavelength of 2.97 meters. Now, if you're trying to build an ideal antenna to pick up this radio station, you think about it and say, well, one complete wavelength is that. Well, if you look at it, half a wavelength really has all the information that you need. In fact, a quarter wavelength goes from 0 to maximum, okay, to the full amplitude. And so if you're going to have the simplest antenna for radio, then that antenna, so the antenna, the simplest antenna we call a monopole antenna, is typically 1/4 of a wavelength. Okay, so for this particular radio station, that would turn out to be about 74 centimeters. So, and this is real close to 101.1 megahertz, is close to the middle of the FM dial. 100 megahertz is closer to the middle, and 100 megahertz would have exactly 75 centimeter antenna. And so that is your ideal length antenna. TV stations have much shorter wavelengths, and so you typically need a shorter antenna. Cell phones are in the several gigahertz range, so they have much shorter antennas. In fact, many of them are up in the tens of gigahertz ranges, and so they have little teeny tiny antennas that can actually be embedded in the into the structure of your phone itself. You don't even need an external antenna. Should point out, some years ago we cut the cable, cut the cord on the cable, and to get some of the local TV stations, I went and bought an antenna, and so for the house, for TV stations. And the way the antenna looks is it's this thing that looks kind of like this. And now really that's not the antenna. Those are all directors for the antenna. The antenna is actually these two little tiny pieces of metal sticking out here, each one of them just a couple inches long, and each one of them has a wire connected to it, which then goes into a little transformer that goes to a coax cable that goes into the house. That's the antenna. All these other things out here are directors that cause the radio signals to bounce back and forth and amplify. Basically, they hit resonance and amplify the signal right there. And so that's how one of these Yagi style antennas work. And that's it. And the ironic thing is, when I went and bought this thing, I was checking out, and the person wanting to check out said, well, do you need an extended warranty on it? And I go, huh? Okay, well, this is a complicated piece of equipment. Do you need an extended warranty to protect you in case something breaks? And I go, it's not complicated. And she asked, well, do you actually know how it works? And I said, yeah, but let me explain. So anyway, But yeah, no, there's no moving parts. There's nothing to it. The whole antenna is just like I said, those two little tiny pieces of metal right there, and the rest of those are simply directors. Now, I will admit they're a little more complicated in how they connected to each other, but I understand how that works too, and that's beyond the level of this class. But this does kind of get the idea. And again, TV signals are quite a bit higher frequency than some of these others, and so that's why the structure is the way that it is. But anyway, that's the basic idea of waves and wavelengths, and that really it comes down to that same equation: C equals lambda f, and this holds for all kinds of waves.